Okay, so in this video we're going to start to look at the what's called the square root property, using that to solve equations. So first consider the equation x squared equal to 4. Now this is an equation that we have solved before. We can set it equal to 0, and then we can proceed to factor the equation because it's the difference of squares. Right, and then we can solve each of those two linear equations, and we get our answers: x equals -2 and 2. Okay, so that's fine and good if it's x squared equal to a number that we can actually factor as a perfect square, like 4 or 9 or 16. But what if it was x squared equal to some other number? So we want to approach this equation from a different point of view, and that's using the square root. Very important. Back when we talked about simplifying expressions involving square roots, we made an assumption that the variables were positive. That way we could say square root of x squared was equal to x. But remember, the square root of x squared is actually the absolute value of x. Okay, very important idea as we continue on now. So what we do to solve the equation x squared equals 4 is we apply the square root to both sides. Now, knowing square root of x squared is absolute value, that would be equal to 2. We can then say, well, because it's absolute value, it's either positive 2 or negative 2. That's kind of how we approached it with absolute value equations. Now we're going to make a small little adjustment to that, and we'll often, when we drop the absolute value, apply that plus or minus to that number. That's typically how we'll write it now. Now when you type it in your homework, you still have to type both answers in separated by a comma, but by hand notation we'll often write plus or minus. Okay. Consider another example. Here we have the equation 4x squared equals 25. Now we could divide to get x squared by itself, so we could divide both sides by 4, but we don't have to, because remember that square roots will distribute over multiplications. Just addition and subtraction they don't distribute over. So we could do square root of 4 is 2, square root of x squared is absolute value, equals the square root of 5, and then we can drop the absolute value. We get 2x equals plus or minus 5. And then divide by 2, we get x is positive plus or minus 5 halves, which means that x is 5 halves or negative 5 halves. Okay. Up next we have x squared plus 9 equals 0. This is an equation that we could not solve by factoring. All right, we could try to solve it by factoring, but we quickly say, well, I can't factor x squared plus 9 because it's a sum of squares. There are no numbers, that I could multiply so that or no factors I could multiply so I could get x squared plus 9. But now, armed with our square root, we have a way to go about this problem. So we bring the 9 over to the other side. X squared equal to -9. We can apply square root to both sides. Square root of x squared is absolute value, and now square root of -9, it's not real, but we can make use of the number I here and take that square root of -9 and rewrite it as square root of 9 times the square root of -1. So we drop the absolute value, that makes it plus or minus. Square root of 9 is 3, and then by definition of the imaginary number, square root of -1 is I. So it turns out the solutions for this equation are plus or minus 3i. Up next, consider x squared minus 20 equals 0. We first get the x squared by itself. X squared equals 20. We can then apply square root to both sides. Okay, and then upon simplifying, and again you may want to take a moment and try to do that on your own, we get square root of x squared is absolute value. For square root of 20, we can't get an exact answer, but we can break it up. Or we can't get a nice answer, but we can still break it up. So we can do 20 is 4 times 5. We do that because 4 is a perfect square. Square root of 4 is 2. And then square root of 5 is left over. And again, when we drop the absolute value, we make it plus or minus. Okay, we'll look at a couple more examples of this in the next video. Until then.